Stand corrected. We're actually going to be looking at paragraphs 1 through 14. Teenage Brains by David Dobbs. Although you know your teenager takes some chances, it can be a shock to hear about them. One fine May morning not long ago, my oldest son, 17 at the time, phoned to tell me that he had just spent a couple of hours at the state police barracks. Apparently, he had been driving a little fast. What, I asked, was a little fast? Turns out this product of my genes and loving care, the boy man I had swaddled, coddled, cooed at, and then pushed and pulled to the brink of manhood, had been flying down the highway at 113 miles an hour. That's more than a little fast, I said. He agreed. In fact, he seemed somber and contrite. He did not object when I told him he'd have to pay the fines and probably for a lawyer. He did not argue when I pointed out that if anything happens at that speed, a dog in the road, a blown tire, a sneeze, he dies. He was, in fact, almost irritatingly reasonable. He even proffered that the cop had did the right thing in stopping him, for, as he put it, we can't all go around doing 113. He did, however, object to one thing. He didn't like it that one of the several citations he received was for reckless driving. Well, I huffed, sensing an opportunity to finally yell at him, what would you call it? It's just not accurate, he said calmly. Reckless sounds like you're not paying attention, but I was. I made a deliberate point of doing this on an empty stretch of dry interstate in broad daylight with good sight lines and no traffic. I mean, I wasn't just gunning the thing, I was driving. I guess that's what I want you to know. If it makes you feel any better, I was really focused. Actually, it did make me feel better. That bothered me, for I didn't understand why. Now I do. My son's high-speed adventure raised the question long asked by people who have pondered the class of humans we call teenagers. What on earth was he doing? Parents often phrase this question more colorfully. Scientists put it more coolly. They ask, what can explain this behavior? But even that is just another way of wondering, what is wrong with these kids? Why do they act this way? The question passes judgment, even as it inquires. Through the ages, most answers have cited dark forces that uniquely affect the teen. Aristotle concluded more than 2,300 years ago that the young are heated by nature as drunken men by wine. A shepherd in William Shakespeare's The Winter's Tale wishes there were no age between 10 and 3 and 20, or that youth would sleep out the rest, for there is nothing in the between but getting wenches with child, wronging the ancientry, stealing, fighting. His lament colors most modern scientific inquiries as well. G. Stanley Hall, who formalized adolescent studies with his 1904 Adolescence, its psychology and its relations to physiology, anthropology, sociology, sex, crime, religion, and education, believed this period of storm and stress replicated earlier, less civilized stages of human development. Freud saw adolescence as an expression of torturous psychosexual conflict. Erik Erikson as the most tumultuous of life's several identity crises. Adolescence, always a problem. Such thinking carried into the late 20th century when researchers developed brain imaging technology that enabled them to see the teen brain in enough detail to track both its physical development and its patterns of activity. These imaging tools offered a new way to ask the same question, what's wrong with these kids? And revealed an answer that surprised almost everyone. Our brains, it turned out, take much longer to develop than we had thought. This revelation suggested both a simplistic, unflattering explanation for teens' maddening behavior and a more complex, affirmative explanation as well. The first full series of scans of the developing adolescent brain, a National Institute of Health project that studied over 100 young people as they grew up during the 1990s, showed that our brains undergo a massive reorganization between our 12th and 25th years. The brain doesn't actually grow very much during this period. It has already reached 90% of its full size by the time a person is 6, and a thickening skull accounts for most head growth afterward. But as we move through adolescence, the brain undergoes extensive remodeling, resembling a network and wiring upgrade. For starters, the brain's axons, the large, long nerve fibers that neurons use to send signals to other neurons, become gradually more insulated with a fatty substance called myelin, the brain's white matter, eventually boosting the axon's transmission speed up to 100 times. Meanwhile, dendrites, the branch-like extensions that neurons use to receive signals from nearby axons, grow twiggier, and the most heavily used synapses, the little chemical junctures across which axons and dendrites pass notes, grow richer and stronger. At the same time, synapses that see little use begin to wither. This synaptic pruning, as it is called, causes the brain's cortex, the outer layer of gray matter where we do much of our conscious and complicated thinking, to become thinner but more efficient. Taken together, these changes make the entire brain a much faster and more sophisticated organ. The process of maturation, once thought to be largely finished by elementary school, continues throughout adolescence. Imaging work done since the 1990s shows that these physical changes move in a slow wave from the brain's rear to its front. From areas close to the brainstem that look after older and more behaviorally basic functions such as vision, movement, and fundamental processing, to the evolutionarily newer and more complicated thinking areas up front. The corpus callosum, which connects the brain's left and right hemispheres and carries traffic essential to many advanced brain functions, steadily thickens. Stronger links also develop between the hippocampus, a sort of memory directory, and frontal areas that set goals and weigh different agendas. As a result, we get better at integrating memory and experience into our decisions. At the same time, the frontal areas develop greater speed and richer connections, allowing us to generate and weigh far more variables and agendas than before. When this development proceeds normally, we get better at balancing impulse, desire, goals, self-interest, rules, ethics, and even altruism, generating behavior that is more complex and, sometimes at least, more sensible. But at times, and especially at first, the brain does this work clumsily. It's hard to get all those new cogs to mesh.